Welcome students, we got an interesting question. We are expected to show that ln of 1 positive x is equal to sigma n is equal to 1 to infinity negative 1 raised to the power of n positive 1 times x to the power of n divided by n. So we need to prove this. So first what I wish to do is I would like to consider integral dx over 1 positive x. Now if you were to integrate this, what do you get? You get ln of 1 positive x. Okay. Now, having got this, what I'm going to do is I would be utilizing this to prove this. So, let me write or rewrite this in this following fashion. Rewriting. We get ln of 1 positive x is equal to integral dx over 1 positive x. Now, can I write 1 positive x as 1 negative of negative x? Can I write it like this? Of course I can write it like this. Now, I would like to bring your attention to a important expansion, a series expansion. Now if you have to have 1 over 1 negative x, this can be rewritten as 1 negative x raised to the power of negative 1. If you have to expand this, is going to be 1 positive x squared positive x to the power of 3 plus etc. If you have to write this as a summation, this is going to be sigma n is equal to 0 to infinity x to the power of n. I'm going to utilize this over here. So in place of x, I got negative x. So if I were to utilize this expansion, therefore I can rewrite 1 negative of negative x to be equal to sigma n is equal to 0 to infinity negative x raised to the power of n, because in place of x you got negative x. Okay, so take this and replace this by this. So let me go back over here. So I'm going to rewrite this as integral dx over 1 negative of negative x. I'm going to push this to the numerator. So it's going to be 1 negative of negative x raised to the power of negative 1 into dx. So this is equivalent to this. This has got this, and I'm going to utilize this with this, right? So substituting in place of x, I'm going to substitute negative x raised to the power of n. So I've already explained to you. So this is going to be integral sigma n is equal to 0 to infinity negative x raised to the power of n times dx. Okay, good, fine, fair enough. Now you got this negative x raised to the power of n. So I'm going to rewrite this as negative 1 multiplied with x, and this entire quantity is raised to the power of n, and you got a sigma n is equal to 0 to infinity, and you got this dx. Now if you have ab raised to the power of n, you can rewrite this as a power n b power n from the law of indices. So this is equal to integral sigma n is equal to 0 to infinity negative 1 raised to the power of n times x to the power of n times dx. Now what I wish to do here is I would like to actually move the sigma out. Okay, I can move the sigma out. Why I'm able to interchange sigma and integral? Because of the convergence of this particular series. This term is convergent. Because of that, this can be rewritten as sigma n is equal to 0 to infinity integral negative 1 raised to the power of n x to the power of n times dx. So this is what I've got. Now I will push this negative 1 outside because we don't have a x here. So negative 1 raised to the power of n comes out, n is equal to 0 to infinity. You have integral x to the power of n dx. Now integrate this. This is equal to sigma n is equal to 0 to infinity negative 1 raised to the power of n. You integrate this, you get x to the power of n positive 1 divided by n positive 1. Okay, the limits are n is equal to 0 to infinity. Now what I wish to do is I would like to make the transformation. I'm going to transform from n to n negative 1. So this is going to be sigma from n to n negative 1. So this will start from 1. This is going to be negative 1 raised to the power of n negative 1, x to the power of n negative 1 positive 1, x to the power of n divided by n negative 1 positive 1. So it's going to be n there. Now this is n to infinity. A very important step. N minus 1 and n plus 1 have the same parity. Okay, have the same parity. So that would mean they will take the same value. So I'm going to replace this as sigma n is equal to 1 to infinity negative 1 raised to the power of n positive 1 times x to the power of n divided by n. Now this is nothing but the right hand side, hence proved. Okay, so this is the final solution to this beautiful question. Please like, share and subscribe to our channel. Please give your comments and have a nice day.